So you should have a sheet of graph paper now, and at the top of the graph paper, you are going to want to mark this with the date, which should be somewhere around 5/3/18. And you should also call this graphing set 2 and set 3. So we have never graphed on regular graph paper before, where you have to establish your own X and Y axis. And so for that reason, I chose 4 that I'm going to go through with you. You use as many examples as you need. The first 2 come from set 1, letters E and S. So when I look at letter E, my final answer was y equals 2/3 x plus 2. And when I'm graphing with slope-intercept form, the 2 things that I'm going to need in particular are the slope and the y-intercept. Okay? When I look at my slope, I need to break it down into my change in y, or how far up or down I'm going to move from one point to the next, over my change in x, or how far left or right I'm going to move from one point to the next. So in this case, my change in y is 2, and my change in x is 3. My y-intercept is positive 2, which means that's going to be the first dot I make on my coordinate plane. And because I start at positive 2, I'm going to design my coordinate plane to make sure that I can fit positive 2 plus moving up 2 and over 3. So what I think I'm going to do is make a coordinate plane that's a little bit lopsided in favor of that first positive quadrant. I'm going to put a little more space here because I'm going to begin by graphing my y-intercept. I'm going to go from the origin up to positive 1, positive 2, and make a dot. And then from there, what I need to do is take my change in y, which is the direction that my point will move up, oops, sorry about my arrow, up from my starting point, and then my change in x, which is the point that the distance that will move over. So I'm going to start here, and I'm going to go up 2, and then I'm going to move over 1, 2, 3. And at that point, I'm going to make my first dot, up 2 over 3. Now, if I really want to make an accurate line, what I would probably do is go in the opposite direction as well. I can see that if I connect the dots, my line is going to be headed down this way. So a really accurate depiction of my line would probably extend this axis over a bit, and I would kind of go in the backwards direction. I can visualize where my line's going to go, and I know that I have to move probably down 2, right? If I went up 2 the first time, to get over this direction, I'm going to go down 2, and then left 3, because that 2 and 3 has to be consistent. So I'm going to make another dot here, and when I do that, I see that I've got a straight line, and this straight line represents my equation. The next one I'm going to work on is also from set 1, and that is letter S. And again, the 2 pieces I need to graph are my slope and my y-intercept, which happens to be the same as the last one we did. What is different, however, is that my slope is a whole number. So I've got to use my fraction knowledge, because my change in y is that 2 that's featured there. But my change in x, my denominator, is that invisible 1 that exists under every whole number and is there when we need it to be a fraction. So my slope of a whole number is whatever that number is over 1. My change in x would be 1. And I've got a similar situation as last time where I'm going to have to be going up 2. So when I make my coordinate plane, I have to make sure I have enough room in the positive quadrant. Once again, because my y-intercept is 2, I'm going to start at my origin and count up 1, 2, and make my first dot there. And then in this case, I'm going to be moving up 2 and to the right 1. Up 2 and to the right 1. Now I'm going to do the same thing I did last time. I'm going to try to go opposite. And I'm visualizing that it's going to have to go down and to the left to make a dot down here. And if I'm going to go down, I have to go down 2 because my change in y, which is sort of that up and down direction, is 2. And if I'm going to go left, I have to go left 1 because that is my change in x. So I am going to, from my starting point again, go down 2 and to the left 1. And when I see that I've made a straight line, I know I've done well. One thing I forgot to mention on the last line is the other thing I want to do before I decide that I'm done is go back to my slope and say this was a positive slope, a positive 2. My line is climbing upwards from left to right. I need to make sure, either using my slope page of your tools packet or just by memory, that that is the way it should be. When I have a positive slope, my line should climb upwards. The next one I'm going to do is letter E from set 2. Letter E from set 2 had an answer of y equals negative x minus 7. This one is unique because, first of all, it's got a negative intercept, which we haven't had yet in this video anyway. The other thing it has is it has that invisible slope of negative 1. Back in 7th grade in pre-algebra, you should have picked up on the fact that every variable has a 1 in front of it. And if there's a negative, then there's a negative 1 in front of it. If you haven't picked up on that, it's really important to learn for slope. If there's no number there, it's the invisible 1 that exists in front of your variable. That also then means that I've got an interesting slope. It's a really easy one to graph. But as I examine my change in y, I know from the last problem we did, when I have a whole number like negative 1, that's going to be my numerator. And then my denominator, my change in x, is the sort of invisible, there's a second invisible 1 that is available when we need to write whole numbers as fractions. So I've got as my slope a negative 1 over 1. As I design my graph, what I know is this negative 1 in the y means that I'm going to have to be graphing down instead of up. And I'm already starting at negative 7, which is pretty low on the y-axis. So I'm going to design my coordinate plane on my paper in a way that gives way more space to the bottom quadrants. Okay? And if I count down from my origin, 1, 2, 3, 4, 5, 6, 7. I haven't even given myself enough space with this. So maybe what I need to do is, I guess I could redo the whole thing, but I'm just going to make this line a little bit longer. That happens sometimes. And I'll go back and try again. Here's my origin. 1, 2, 3, 4, 5, 6, 7. I'll put a dot right there. Okay, I had to count again with my marker. Okay, there's my starting place. And now what my slope tells me I need to do is I need to go down 1 and then over 1. So I'll go down and over, down and over. These are nice ones because they make perfect diagonals. As you move from point to point, a slope of 1 or positive 1 means that from this point now, I would continue and go down 1 over 1. You're really just following the diagonal of the graph paper. Now once again, I've got this problem where I keep on moving down and to the right, and I think it would be helpful if I continued my line up this way. Because it's a slope of 1, it's really easy to see that we would just follow the diagonal of the graph paper, but you can also see that I would just be doing the opposite of what I did here. Here I went down and to the right, and as I move backwards, I would go up and to the left to continue that line. It's kind of like a mirror image almost. Up and to the left 1, up and to the left 2. And there I've got a pretty decent amount of dots to make a line that represents that equation. All right, the last one I'm going to give as an example is also from set 2. It's number 6. I've got my slope of -4/3. That's the most in this video that I have had to jump. I haven't had to jump up 4 or down 4, and I haven't had to move left or right 3 yet. So I'll have to think about the way that I'm building my graph so that I can do that. I'm starting on +5, which means I'm starting quite high up on the y-axis. My change in y for this is -4, which means I'll be moving down 4 to start. And my change in x is +3, so I'll move to the right 3. I'm going to design my coordinate plane a little different this time. What I'm going to do is I'm going to count by 2's this time so that I have more room to make more dots. Oops, that was not a very good line. Let's try that one again. So if I count by 2's, I can still make my y-axis, or excuse me, my y-intercept of +5 because I can go like this. 1, 2, 3, 4, 5. If it helps you, you can make those little marks in between each of your grid lines to show those positive numbers. Excuse me, those odd numbers. So I'm going to count up to 5 and make my y-intercept, okay? And then from there, I'm going to go down 4 and over 3. So from here, I'll go down 1, 2, 3, 4, and over 1, 2, 3. Now you notice I didn't have to also count by 2's on my x-axis, but you could if you wanted to. I'm just counting on the regular ones to the right because I think I have enough to go to the right 3. So once again, let me go down 4, 1, 2, 3, 4, and to the right 1, 2, 3. I think I have enough. I think I could probably even estimate one more. I could still go down 4 more. 1, 2, 3, 4 would be right here. And over 1, 2, 3. If I make a dot right there. I've got a pretty decent line. So you are allowed to number things. You don't have to go by ones, and you're allowed to do different on the x and y axis. The idea is when you're done, if you have a negative slope, your line should be going downhill, and you should always be making a straight line. If you feel like one of your dots isn't quite in the right place, you might want to double check your graphing and see that you've done your slope properly both times.